So a brief history on modified bitumen systems. Really it gained acceptance in Europe in the late 1960s and 70s. So the technology combines bitumen with polymer additives, and there's two types of additives that are used. Styrene, butadiene styrene, or SBS, and APP, which is atactic polypropylene. So the most common that you'll find in Canada as a modifier is the SBS. So the big question is, why use modifieds? How do the additives help? That sort of thing. So asphalt, which is derived from petroleum, and it's a mixture of carbon-based solids and oils. When polymers are added to the bitumen asphalt, they cause the molecules to swell, and this holds the oils in place. This increases the longevity and performance of the SBS membrane and produces a high flexibility, even down to minus 30 degrees Celsius. So modified bitumen systems have been performing in Canada since the 1970s, and that's in all climatic zones. Another key component that makes up the membrane is the reinforcement, and then there's three types of reinforcement. The first one is fiberglass mats. The second one is a non-woven polyester, and the third one is a composite, which is a combination of the first two, the fiberglass and the non-directional polyester. The roofing systems themselves are made up of two layers, a base sheet and a cap sheet. So that's in the field as well in the flashing details. So the surface of each one of the sheets, they're going to change slightly depending on the three sections and the three different systems that we're installing, but it'll be based on and depending on the securement for each assembly. So there's mechanically fastening, there's self-adhesive, cold adhesive, hot adhesives like asphalt, and of course heat welding. You see John on the far side. So another important note for the CRCA and the YRCA is that with respect to heat welding or hot roofing, CRCN members are deeply committed to roof safety. As such, they have developed a heat welding course for roofing applicators. This training teaches all aspects of working safely in a heat welding environment. So I had to read that. So just a quick review of the existing assembly. We have a variety of different vapor barriers that have been installed onto the steel deck. Mechanically fastened polyiso insulation that's available in 4x4 and 4x8 panels. On top of that in the field you'll see a base sheet and a cap sheet flashing, and in each one of those sections. So across here, and again the three sections that we'll be demonstrating today is a mechanically fastened base sheet with a heat welded cap. Section 2 will be a self-adhered base sheet and self-adhered cap. And section 3, to your immediate left or my right, will have a cold applied base sheet and cap sheet. So if we look very quickly over to the first section on the far side with the two Johns, this is a mechanically fastened base sheet. So have a look at the membrane itself. You're going to see a polyfilm on the top side of that membrane, and this is to facilitate a proper bond when heat welding the cap sheet to this base sheet. Also with mechanically fastened assemblies, and they'll vary by the way depending on the manufacturer, so I encourage you again to go back, visit them, and they can cover off in more detail regarding spacing, width loads, types of pressure plates that are suggested. But for here, the pressure plates are installed on the side lap, and just ensure that they're aligned properly so they can be, again, sealed and made watertight.
Okay, you can start rolling it up.
The one way to check to make sure when you're heat welding on is it will be a visible indicator is on the side lap and your end lap will be what's called a bleed out. So again, based on the manufacturer, that bleed out will vary depending on what's acceptable or what's warrantable by that specific manufacturer. So check with back at the booth as well. So looking at section 2 in the field is a base sheet self-adhered. So again, depending on manufacturer, you will have either a pre-primed area. Some manufacturers don't require that. On top of that pre-primed area, you'll see here in section 2, they've laid each one of the membranes out. By the way, it's very critical that they're relaxed before they're installed. Different methods are used as far as removing the release film on the underside. Once the release film is completely removed and it's laid in place, they'll roll this with a heavy roller to ensure, again, proper bond to the substrate. Over here in section 3, which is the cold applied base sheet and cap sheet, installation of the cap sheet is the base sheet is proceeding. Again, you need to use a squeegee, which is a notch squeegee. Some manufacturers are an 1/8 inch notch, some are a 1/4 inch. Ensure that it is done in a proper pattern. Again, and this will guide, the squeegee will guide on the thickness of the adhesive that's installed. Again, they relax the rolls, they re-roll them out, fit them, and then re-roll it again to the middle and install the adhesive. Just having a look at the membrane that they're installing here on the base sheet, you'll notice that it's a sanded surface. Again, we've got a poly film over here, as well as a synthetic film on section 2, and section 3 is sanded. And again, that's to facilitate and allow for the adhesives to bond directly to the modified bitumen and to bond it down onto the substrate. You're always working as well from the low portion of the roof, typically a drain or on a lower elevation, and working your way to the high. Again, so you're not bucking any of the laps with water flow. Back on section 1, on your far left, John is working on a corner here. He's got he used the igniter. They're using propane. This is fairly standard in North America, but in particular in Canada, as the fuel that they're using for any type of heat welding. There's other hot air equipment that we can talk about later, but for these purposes, he's using the smaller handheld torch applicator. Also, John is using, to assist him to ensure a proper bond with the base sheet in the corner, an aluminum applicator, as well as hand rollers. There's a metal hand roller that they'll be using at this time. Base sheet flashing is always pre-cut, dry fit. Ensure that everything is in place. Once he lines it up, he'll then release. They're using a self-adhered base sheet for the flashings. He's working from the top down. Once he fits that down, also he wants to make sure that the base sheet is tying into the field a minimum 4 inches. There's a 45 cut on every lap as well to facilitate flow of water and to minimize the buildup of membrane on those side laps. He'll have a 2-inch wraparound coming on the inside corner, and he'll also seal it up and over the parapet to ensure proper waterproofing. And then later on, usually at day's end, they'll mechanically fasten the return on the fascia, depending on what the designer has put into place. It could be 12 inches, 18 inches, or 8 inches on the fasteners on the fascia. So section 2, self-adhesive base sheet flashing. Again, they're pre-cutting it. They'll do a dry fit to ensure that it's seated and installed properly. Once that's in place, they'll do a tie-in with a 4-inch onto the field base sheet. All of the self-adhered membranes, base and cap sheet, are pressure sensitive, so they have to be rolled in place to forces the air out and to get a good bond. Moving over to section 3, cold adhesive base sheet. They've already relaxed that roll, as you saw. They've re-rolled it back to the center. They adhered, or put the adhesive down, not squeegee on the upper side. Now they're going to lay it down, the cold adhesive on the second side here. And again, once that's in place, they're going to roll the membrane to ensure a proper bond. Just mentioning too, I know Daryl had in the introductions was talking about safety equipment. So normally, if you're on on site in a real world scenario, they would also be using harnesses and safety equipment or safety barriers. So for this demonstration, it's not necessary. But I just want to be mindful again of the safety, especially over in the torch section here or the heat weld. You'll see safety equipment as far as fire extinguishers, ear protection, eye protection, long sleeves everywhere. I see it. So over in section 1, they're just making sure that they clean up and making it safe, and they'll be moving forward shortly with the installation of the cap sheet once the base sheet flashing is completed. So in section 1, if you have a look, John's over here. He's also ensuring that all the side laps and the end laps are feathered and bonded. This is critical to ensure there's no bridging, there's no gaps, and that you get a clean, solid bond to the upstand or the parapet substrate. Just moving over to section 1 here again, there's a critical component within any corner, inside and outside corners. This corner that's being demonstrated by John is what's called a gusset. And again, the manufacturers will vary on what's required by the dimensions of that gusset. But the function of it is to facilitate to waterproof the hole, that small hole that will be present regardless of the planes of the sheet products that are moved together in that very point, in that very corner. Once that's in, now you've got it completely waterproof. Manufacturers will want to see this done at the end of each day. That way they ensure everything is completely sealed before starting in case it rains that night. So section 2, the self-adhered cap sheet is now being installed. It's got a release film again, so normally what they want to do is they want to relax that roll, which we talked about earlier. They'll re-roll it up, make sure it's aligned, get it to ensure that the side lap of the cap sheet and the side lap of the base sheet are within the required distance apart. You never want to see a side lap of a base within a certain distance. Some manufacturers say 12 inches, but then the side lap of the cap. And again, this is just to ensure you build in some extra redundancy regarding waterproofing. Over here in section 3, they're now applying pressure to ensure that it is indeed fully bonded. It's always important to be mindful of the adhesive if you're happily married, because this here has a tendency to find its way on your clothing and eventually making it into your home. You got the gusset in place? Yeah. Again, over here, just carry on with section 3. He's already has the gusset in place here. And again, same material that you'd use on your field and flashing as far as surface. It'll be a sanded surface to facilitate the use of the adhesive for the bond. But again, that's critical that it's in place. So moving over here to section 2 in the field. Chris is removing the release film on the back side of the cap sheet. Again, he's ensuring that it's lined properly, it's relaxed properly. Once he's satisfied with that, these films are released. And then, if you can remember, the critical point is pressure sensitive. They will roll this. If I could draw your attention over to section 1 again, John number 2. He's fitting into place, making sure it's pre-cut, making sure that it's dry fitted. And he will heat weld the cap sheet to the base sheet. Also notice the underside has a poly film, as well as the top side of the base sheet has a poly film. So that will facilitate, again, a proper bond. Notice the motions that they're using with the heat welder or with the torch. It's in a rectangular, steady movement. And the trick is that you want to be able to heat up the existing base sheet that's installed, as well as to create a melted film on the cap sheet. This in turn fully bonds the base and the cap together, and they'll perform as one. John's in the corner with the long torch. The hand trowel that he's using now is instrumental too as far as getting into the detail corners to ensure again that it's either embedded the granules or that it's fully pushed into place. The tie-in on the cap sheet, section 1 still, is again, it has to be 6 inches. And if you remember, you're offsetting the tie-ins. The base sheet came down 4 inches and the cap sheet comes down 6 inches. So that you want to make sure they're staggered as well for some redundant waterproofing. We'll talk shortly here on section 1 still. He's going to do an end lap. End laps, again, you can fully embed the granule. This is critical. Once it's fully embedded, 6 inches, he'll again heat weld the cap sheet to the base sheet and overlapping on the previous one, that's 6 inches. He's also using what's called a cane, and that'll help him direct the roll and control the roll, speed as well as allowing him to move his fuel line out of place if it happens to go in front of the work area. Again, he's fully embedding it, pushing it in, getting a solid bleed out. Consultants as well as manufacturers and owners want to make sure they see that bleed out, then they can visually check to ensure that it's properly bonded. Section 2, next portion of the self-adhered cap sheet is being installed. It's already been relaxed, it's pre-cut, it's fitted. Chris and Corey are removing the film on the one side. This is a split back. Section 3, moving over here to the cold applied system. They're just working on this corner here. They've already installed the adhesive. It's again a notched hand trowel this time rather than the squeegee. Gusset is installed. Again, he's pre-cut it, fitted everything, because once you set it into place, even though you can move it, just to control the adhesive doesn't get everywhere. And they'll quite easily install that. Once it's down, again, they'll roll it like we talked before previously. Shifting back to section 2, or correction, section 1. Just before they start the torching on the cap sheet, because you might not be able to hear me. Again, they've relaxed the roll. They've once that's done, they've re-rolled up half, so it's aligned properly. He'll heat weld the first section. Once that's done, they'll re-roll the alternate and heat weld that down. This way, you minimize any chance of any wrinkling or blistering. John will continue on now doing repetitive with the cap sheet sections for the flashing. Again, with a 6-inch tie-in. And again, they're working from low point to high point. John will be moving that in, again, a continuous rectangular motion, heating up the base sheet in the field and the cap sheet field that's being installed. Again, the cane, specialized product, will control the speed, and he can also adjust the torch depending on wind factor that may be involved in that as well. Moving over to section 2, in the middle. What's happening in the backside is they're using an adhesive, rather than embedding the granules, they're using an adhesive to coat and impregnate the granules themselves. Coming onto the field 6 inches. Sam? Sam? You got your cap down? Your cap is down. Second ply is, the second ply is good, huh? You're just about done? You're gonna come down here. Having a look at section 2 here with the self-adhesive, again you'll get a better view of the 6-inch end lap for the cap sheet. Again, they're using a cold adhesive. They're going to cut the 45 as per normal. Thank you, Chris. Once that's brought over, the end lap for the cap sheet in section 2 here, again, pressure sensitive, the field technicians will roll that in place. Section 3, Mike's just working in the corner now. They're installing the second membrane, again in a full bed of adhesive. He'll be bringing that down 6 inches, notched hand trowel again. If I could draw your attention over to section 1 now, John's, once it's relaxed, he's re-rolling this side of the cap back to the middle. This assures again that it's properly aligned. Yeah, whenever. Again, John just lit his propane torch with his igniter. For the demonstration, they have their torches turned very low, by the way. This on a site, when this is happening, this will be proceeding, as you can appreciate, a lot faster. But just to help you folks be able to view it better from the monitors, they're slowing it down for you. Again, full rectangular motion of the heat welder on the cap and on the base equally. I could draw your attention to section 2. Just look at Corey. He's got what's called a hot air gun. There's different names and manufacturers, but a generic name is a hot air gun. It's power driven. It's like a super, well, it's a heat welder. So he'll just wants to make sure that he has a good bleed out and a solid bond on the end lap. Most of the roofing contractors carry these in their vehicles. You have a look at the cap sheet flashing for the self-adhered. Again, he's using the hand rollers. Pressure sensitive. So John's just about finished now with the heat welding of the cap sheet in section 1. So in section 3 here, Mike and Sam are just finishing up on their final piece of flashing for the demonstration. It's always important to make sure the job site is clean. All the trash is picked up, put away into the bins. John's now over on section 1. If you could pan over to section 1. John's using what's called a heat gun. Again, for safety reasons, just checking the thermal reading to ensure that the temperatures are within the safe parameters. Once he's satisfied with that, again, depending on the province that you're in, they'll have certain watches set up, again, to ensure that everything is properly monitored. That's good. You good's good. Ladies and gentlemen, that brings the end of the demonstration. What you have observed today is the application of modified bitumen membrane systems. The 3 systems that were covered, section 1 was a heat welded and mechanically fastened base sheet. Section 2 was a self-adhered base sheet and a self-adhered cap sheet. Section 3 was a cold process, cold adhered base sheet, cold adhered cap sheet. Again, if you have any questions you want to talk briefly with the field technicians about, I invite you to come down, have a quick discussion. But if it's more detailed, please go back to the booth for the manufacturers that sponsored this demonstration today.